All right, so in 12.1, you started with just like the number of ways something can be done. And in the beginning, okay, in the beginning, you were just figuring out like the number of ways something can be done. So like if there was multiple things happening at the same time, you're literally multiplying how many of each one, right? So this was like rolling the die and flipping a coin, right? And it just would ask in the beginning how many different combinations can be made, right? And this would be the 6 options for rolling the die and the 2 for flipping the coin, or 12. So in the beginning, it was just things like that. You also in the beginning had area probability. I think that was in 12.1, where if you had like a box and you had the dartboard thing and you had to figure out the probability of getting it in the circle. So you would put the probability of the circle or what you want.
Who does Bella think she is?
Shush.
The day before.
Over the area of the whole thing. So those were questions like that. So if I asked you, what's the probability you're going to get in the circle, you would do the circle of the whole thing. What's the probability of getting on the board but not in the circle, you would do the whole thing minus the circle over the circle. So things like that. Yeah, yes, if I'm going over it, why do you think I'm going over it?
Because it's going to be on the test.
Probably going to be on the test. Marsh, does that answer your question? Yeah. Okay, good. In 12.2, we talked about the complement of something. So if I told you that the probability of A is 0.3, then the probability of its complement, which was the A bar, is what? How do you find the complement? 1 minus the probability.
AKA 0.7.
Good. So in this case, it would be 1 minus 0.3, which is 0.7. You had charts, so that like if you're looking at your quiz number 5 where you had the chart and you had to read the chart, number 10 where you had to read a chart, you had to read the chart, stuff like that. You talked about I should put it over here because it doesn't fit, the difference between theoretical and experimental probability. And what's the difference? What's the difference between theoretical and experimental?
Theoretical is in the perfect world, and experimental is when you do the test.
Good. So on your quiz, it was the spinner, right? Oh no, it was the deck of cards. But we had one where it was like the spinner. If you had a spinner of 6 colors, each one had its own space, then theoretical would be 1/6 for each color, right? But then if you actually get a data chart and it happens differently, let's say you spin the thing 10 times and 2 of them are red, then 2/10 or 1/5 is your experimental probability. And we had questions like 12.4 was independent and dependent. This is your and independent or dependent was based on things like, did you start with a fresh batch every time? Was there replacement? Did you put it back? That's the difference, right? So if it's an and statement, you then have to figure out, is it independent or dependent? If it's independent, wow. If I could spell today, we would be good. Independent. My brain is working differently than my pen.
Are you sure this is right, Ms. Christopher?
I am now. Okay. In independent, they do not affect each other. And the probability of A and B happening is the probability of A times the probability of B. This is, you pull a number out of the hat, you put the number back. Okay? Sure. So probability becomes an and statement, which means multiplication. And then is it independent or dependent? If it's independent, you just multiply them together. If it's dependent, yep. Okay. If it's dependent, then you're doing the probability of A and B. But this would be like you pulled something out of the hat and you kept it. And that would be the probability of A times the probability of B occurring given A has already occurred. you are assuming that it already happened. So this would be you're pulling a number out of the hat, you're keeping the paper, and then you're pulling a second number out of the hat. Or you're taking a shirt from the drawer, you're keeping the shirt out, and you're pulling another shirt from the drawer. You're eating a piece of candy, and then you're getting a second piece of candy, okay? So that would be dependent. What you did the first time affects what you got the second time. And this is 12-2, is that what you said? Yeah.
Wait,
Wait, what?
if this is 12-2, and the last one wasn't, then what is the last one?
Actually, it would also be 12.
What?
because it's adding
12-4 was the or. And the or is your disjoint or overlapping. Then 12-5 was permutation combination.
Can I get a
Hang.
pick for the roll?
Yeah.
Is it gonna be like how it was on the quiz and it tells us it's gonna be independent or dependent?
What do you mean?
Like, is it gonna give us?
If it just gives you probability, like the numbers,
Yeah.
yes. But there was another formula that we learned that we used the numbers for, so it might be different that way. Okay, then the or came, and this is where you have to know if it's disjoint or overlapping. The or means add, not multiply. And the or disjoint means they can't be both, right? So you're talking about a red card and a club. A red card cannot be a club. Those would be disjoint. Rolling an even or rolling an odd. Those cannot both be the same. Pulling a 10 and pulling a king cannot both be the same, okay? Those would be disjoint. So you would do the probability of A or B equals the probability of A plus the probability of B.
That's disjoint.
That's disjoint. It cannot overlap. Two completely different things. Overlapping is they can both be the same thing. So pulling a red card and a heart, or a red card and a jack, or rolling an even number and a number bigger than 4 can have overlap. And those are probability of A or B equals probability of A plus probability of B minus probability of A and B.
Is that all that's in 12-4?
Yes.
What about that last?
That's permutations, combinations. We're getting to that next. So these are the ones that, one, you used obviously like logic based, like just questions about the cards and the dice and all that stuff. But you also had the big long word problem in which you got given things about something being and an or. So if your word problem involves both and or, then you're using this guy on the right-hand side. So if you go back to 12-4 and you look at we did the last two examples, had stuff like that. And then there was one in the homework like that. It's like the cars, right? It was car, that could be a car, and also a gray color, like that kind of a thing. So if your word problem has the and the or mixed, then that's your overlapping statement. Yep. Nope.
You like Loki's?
Nope. 12-5 were permutations and combinations.
AKA calculator lesson.
Sure.
You're not gonna make us do the equation on the test.
What?
You know how we use the calculator for the questions?
Yeah.
Are you gonna make us do the other way?
No, but there were times that we used the other way. Yes, okay. The other times that you had to use the other way, like when we did the probability ones, you had to in order to simplify it. Yes, you don't want to be simplifying something that's like to the millions over something that's 100,000, or the other way around, but yeah.
Are we gonna have to simplify the test?
Of course. Okay, so a permutation is when order matters, right? So we did these first and then we added in the combination. So when order matters. And there were two types of permutation. When the whole set is used, when I want to arrange all 35 of you, when I want to figure out how 9 runners can finish, when I want to figure out how 10 songs can be put in order, and those are all the number factorial. So however many there are, factorial. And then there's a specific number at a time. And those are your P, N, R. Where N is the whole set and R is the number at a time. So this is how many ways can you finish first, second, and third?
What does the bottom say?
P and R. Oh, number at a time. This is if I have a word and I want to figure out how many different ways I can pull a specific number of letters out of it. That would be permutations. And then combination, the order does not matter.
So if permutation is like you take out specific letters of a word and rearrange them, then what would combination be?
It would just be like you pull 3 letters and you put you separate out 3 letters. And the order doesn't matter of those 3 letters.
Huh.
Right, but if you're putting 3 letters in specific order, now it's the permutation. Mm-hmm. There is no whole set combination. So combination is only number at a time. And it would be C, N, R. Oh, let me write out this formula just in case. But this is N. So should somebody forget their calculator, there will be none given. Keep that in mind. And it has to be the specific one. So the permutation is N factorial over N minus R factorial. And the combination is N factorial over N minus R factorial times R factorial. Hang on. Within these, you also have probability questions. So the probability questions you had for permutations, the ones that were a little tricky were the ones, let's say, what's the probability of your friend finishing first and you finishing second? This is the parade float one, the other one like that, right? So this is where you have to do the total in the bottom. And in the top, you remove the first 2 places. So it'd be N minus 2 factorial. Or however many places. If you want to figure out how many times you would finish first, your friend finishes second, somebody else finishes third. Now you're going to take away the 3 of them that are already spoken for. Whereas combination, it would be you and your friend finish first and second, but it doesn't matter which is first and which is second. And that would be 1 over the combinations, the total number of combinations.
So be like, wait, what, can you give me an example of that? Please.
I just did. So the first one is what's the probability, there's 10 people walking in a race. What's the probability that you are first and your friend is second? That's that first one. That's this. You have a specific, you want to be first and your friend wants to be second. The second one is there are 10 people walking in a race. What's the probability that you and your friend are first and second? Not you are first and your friend is second. But the 2 of you finish in the first 2, let's say.
That would be 10 would be N and 2 would be R.
Right. Yep. So when you think permutation, there's a specific role within the subset, whereas combination, there's not. Your top 2 would be combination. Your first and second would be permutation. Okay. Okay, so 14 is how many ways can they finish in the race? So you can finish first. We can go 1, 2, 3, 4, 5, 6, 7, 8. Or I could put you to the end and 2, 3, 4, 5, 6, 7, 8. Or I could put you to the end. So now you're talking about the different order. Does that make sense? Yeah. Okay. Anything that's like an order of finish is going to be the permutation.